Quadratic functions can be in three forms. We've discussed standard form, and today we're going to look at graphing in vertex and in intercept form. So it's going to make a little more sense when we have numbers instead of like A's and X's and H's and P's. But those are the forms that you guys are going to see in it, and they're called vertex and intercept form because this form over here actually gives you the vertex when it's in that form, and this one gives you your x-intercepts when it's in that form. And we'll see that when we do an example, but we're going to look at vertex form first. So when a graph is in vertex form, you're going to have one parentheses with a squared exponent on the outside, and you could or could not have a value added on at the end. So the graph of y equals x minus h squared plus k is the parabola, or the parent function, ax squared, is just translated horizontally h units and vertically k units. So in this equation, your h is your horizontal shift, whereas your k is the vertical shift. So if you look at that graph to the right there, the blue function is the parent function, so this red function is the one that's been moved, and it's moved right h units and up k units. So if you take notice in your equation, the h is minus h, but we went to the right. So that's why I sort of wrote down here for your bullet, the vertex is given hk, but h is actually opposite. So if it says minus 5, you're actually going to move to the right 5. If it said plus 2 on the inside, you'd actually move to the left 2. The reason that is because it's always minus your value. So it would minus a negative 3 on the inside of those parentheses. We wouldn't write it as a minus negative. We just write it as x plus. And that's how it becomes the opposite. And then your k, or your vertical shift, is just always the same. So if it's plus, it's going to be up, and if it's minus, it's going to be a downshift. So let's look at doing an example together. So the graph y equals 1/2 x minus 1 squared plus 3. So it wants us to label the vertex and the axis of symmetry, and then also evaluate 2 more points and take note of the concavity or concavity. So that just means, which way is it concaving? Is it opening up or down? Well, because our a value is positive, we know without even graphing it or doing any work that it's going to open up. So it's going to concave up. Now it doesn't ask, but if it concaves up, that means it's going to have a minimum value. So let's identify what the vertex is. So we like when it's in this form because it's super easy. Literally, you look at your equation and it's minus 1 on the inside, so that's actually right 1 and up 3. So your vertex is positive 1, 3. So you guys can graph that a while if you want. Now remember, if we have the vertex, the axis of symmetry is always through the x value of your vertex. It goes through the middle of your parabola. So your axis of symmetry for here, for this problem, is going to be through 1. You can say at x equals 1, I just like to write through the value of 1. And then it asks us to evaluate two more additional x values. So I'm going to do -1 and +3. I'm going to put my vertex in here since we've already calculated that. So if we plug in -1, we have 1/2 times -1 minus 1 squared plus 3. So -1 and -1 is -2 squared is 4. So 4 times 1/2 divided by 2 is 2 plus 3 is 5. And then if we plugged in 3, 3 minus 1 squared plus 3. 3 minus 1 is 2. 2 squared is 4. 4 times 1/2 is 2, and 2 plus 3 would also be 4. And that makes sense because parabolas are symmetric. So let's plot our points on our graph. So the vertex is at 1, 3. It is going to open up. And then -1, 5, and 3, 5. And it is a little wider because that 1/2, that value smaller than 1, does sort of squash it or make it wider, compresses it a little bit. And that is it for your vertex form of a quadratic function.